Hi, this is Mrs. Han. I'm going to be explaining this gizmo on evolution, natural and artificial selection. So make sure before you do this activity that you understand the difference between artificial selection and natural selection, and hopefully you've gone over some of the videos and information in your course. So here is a nice picture of all the different dogs that we've made using artificial selection by choosing different traits that we like and breeding dogs of the same traits and then getting more offspring that look like that and slowly changing the look of dogs into different breeds. Okay, so we're going to go ahead and do this gizmo, which is a little bit time consuming and can seem confusing. But you just have to read the directions carefully and not miss where it says to select something. So first we're going to do a little warm up with artificial selection right here. I'm going to go ahead and click artificial selection. And we're going to drag these insects into their breeding alcoves. All right. So these are their breeding alcoves. Here are the insects that are going to be breeding, giving them a little privacy, and then we'll see their offspring. Boom. Okay, so these are their offspring, and anything that's circled is an insect that has a mutation. So most of them do not have mutations. They don't occur very often, but once in a while you'll see a mutation. So you'll notice that all the offspring have genes that are white, alleles that are white, but this one happened to have one mutation where it has a little black allele. Okay, so you're going to go ahead and answer those questions. Now let's take a look at activity A. We're going to click on natural selection this time, and we're going to look at average fitness. So average fitness is how well it's adapted to its environment. How fit is it for survival, to survive and reproduce? So the higher this number, the better its chances are for survival. Better it's adapted to its environment. Okay, so we're going to go ahead and click play and see what happens at each generation. So they're breeding, they have offspring, birds come and eat part of the offspring. The remaining ones will survive and reproduce. Some of them get eaten, and then the remaining ones go ahead and reproduce. So that seems to be what's happening every generation. It says to increase it and pause it after 30 generations. So I'll go ahead and speed it up. This is the generations right here, so you can see. If you go too fast, it's hard to stop it at the right spot. Oh, yeah, see? All right, so supposedly I was supposed to stop it at 30 and then look at the average fitness. And you'll notice that whatever your number, it should be higher than 51. And you'll also notice that, look at the beetles or whatever these are starting to blend in more and more with their environment color. Okay, so their fitness is increasing. They have a higher chance of survival when they can have this color that matches their environment. Okay, so now we're going to, I guess we should have gone to 30 generations, but we'll see if I can, how quick my reflex. Oh my gosh, I need to turn this down. All right. I can't. All right, last chance. Oh, not bad. Okay, so my average fitness is 82. I'm going to go ahead and slow it down, and then I'm going to click play and pause when the offspring appear. All right, so here are some parents, and here are their offspring. I'm going to go ahead and choose a pair of parents in which both parents have different colors. So it's hard to see, but this does have a different color than this one. So, and if you click on it, you can see that the alleles are different. Okay, the alleles are the version of the gene. So I'm going to go ahead and pick this one. So I'm going to write in for this one, the genotype is going to be WWKWGG. Now, if you can't write on this part, then go ahead and write their genotype here, WWKWGG, and then for the phenotype, you can go ahead and put the numbers 128, 213, and 128. So this is the phenotype is the color, but notice they're not like just red or blue or green. They're like different degrees of red, blue, and green. So you're going to do the same with this parent. You're going to go ahead and put their genotype, its genotype, and then you're going to go ahead and put the genotypes of these offspring right here. This offspring has a mutation, so it's going to be a little bit different than each of the parents. It's going to have an allele that's different because it has a mutation. So let me see if I can notice which one. Yeah, you can see. Oh, it has. Let's see. The CGG it got from this parent, so you can see that one. But that means WKY. Yeah, WKY. This is where the mutation was. So it got that. Got this chromosome from this parent, but this is the mutation. But all the other ones do not have mutations, so you'll be able to see that one of their chromosomes they got from one parent and one they got from the other. Okay, so you're going to go ahead and do that for the offspring. You're going to go ahead and explain where they got their chromosomes, how they're related. Okay, and then look at the mutations and see if any of the mutated insects survive. Okay, and then you're going to increase it and see what happens as time goes by. All right, so now let's look at activity B. And this is where we're going to be selecting the insects that survive, selecting the insects that mate so that we can create a color of a beetle on our own. So right now, naturally, the nature seemed to select green for these insects. But we're going to see if we can select a color artificially by just breeding and choosing mutations that we want to choose. Okay, so we're going to change the mutation rate to 2.0 so that we have more mutations coming up. Normally, mutations don't happen very often, which is why it can take a long time to breed new traits. Okay, so I'm going to try to breed. I wonder if we have to reset anything. I'm going to try and breed a, what color do I want? Something red. Black? I'll go for black. Okay, I'm going to look for black. Okay, so I'm going to go ahead and slow the speed down. Oop, I need to go to artificial selection. Okay, that changes it. Okay, so that reset it. Now we've got the mutation rate, and I need to, okay, here we go. I said black, but that's because I saw black, but now let's see how this works. This is where your patience comes into play. All right, let's see what mutations I see. So I see a green, blue, and black. Okay, I'll stick with black. So I need to select half of them that are not going to breed. They're not going in a garbage can. They're just being set free. Okay, and then I do want to breed this black one. I will go ahead and keep the rest. Going to be some interesting colors. The rest, so that's the only black one I can breed at this point, but hopefully more black ones will come. All right, so I see this one has black, this one has black. Okay, these are all white, so I'm going to get rid of those. So since this is artificial selection, I can pick and choose which ones I'm breeding and which ones I'm not breeding. It's like when you have a animal that you want to breed, you know, you find the one that has all the traits that you like, and then that becomes the one that you breed. All right, so here's one with the black allele. Here's one with the black allele. I'm not going to breed them together because I want to try and get as many offspring. All right, so see how this is a little time consuming. I'm going to get rid of anything that is not carrying a black allele, which is most of them. Okay, and then I'm going to keep breeding. This one has black, this one has black, this one has blue. Okay, so I'm going to go ahead and pause it so that you don't have to watch this painful thing. See if I can do a few more generations. Okay, I decided to stop around generation 11. I noticed that if you look right here, all my parents had black alleles, and most of the offspring had black. This one has a little yellow, so it's not perfect, but I tried to have most of them be black. All right, so I'm going to go ahead. It says to produce for 5 generations, but then it says here to keep producing insects to match your goal color. And then when you finish, you can do a screenshot. You can, actually, I didn't right click, but I, see, right click to copy, so copy, and then I can go here and I can right click and paste. Okay, so you can do that. If that doesn't work on your computer, then you can feel free to just take a picture with your phone and submit that separately. Here is another way to do a screenshot if you want to. Okay, and then you can answer the questions. Probably can't compare with your classmates. Okay, and then what you're going to do is once you've done that with artificial selection, you're going to go ahead and move these sliders to try and match as possible, the background as possible to your phenotype of insects. So here I'm going to try and match the color to be, I need to take this green down, to the color of my black insects. I'm not really good at color matching, but perhaps this matches. I think so. Okay. And now I'm going to see how long it takes to do natural selection to get to a 90% fitness. So let's go ahead and go here and see how many generations it's going to take to get to 90. So there, I'm going to go ahead and try to speed this up and then pause it when it gets to 90. Okay. Okay. So let's pretend this says 90 and I would put 33. Let me see if I can, let's try it again. Whoa, all right, that speed is just too high. There's no like middle, okay. Let's go ahead. So I'm going to do that 5 times to see how many generations it takes to get these insects to a 90% fitness. And then I'm going to take an average. And you're going to answer the question, which process tends to occur more quickly, natural selection or artificial selection? So we can look at artificial selection. How many generations did it take for us to select out the beetles so that they ended up being the color that you wanted? And how many generations is it taking for it to happen through natural selection? Okay, that was activity B. And our last part of this lovely lab is looking at mutation rates. So we're going to go ahead and click reset, make sure we're on natural selection. Okay, I can't hit reset right now, not sure why, but I'm going to go ahead and set the red to 100, the green to 255, and then the blue to 50, and the mutation rate is going to be 0.1. So now there's going to be very few mutations that happen per generation. And we're going to go ahead and click play, and we're going to pause it and record the number of offspring that have mutations. So we'll just do 1 generation. So let's go ahead and hit play. Okay, hold on. Play. Okay, I need to slow this down. Play. All right, and how many offspring have mutations? None. So I'm going to go ahead and put 0. And then I'm going to do it again. That was my first trial. How many have mutations? None. Okay, so go ahead and do that 1 more time and then take the average. Then you're going to move the mutation rate up to 1. Okay, and perhaps we will see more mutations. So I'm going to just have it play for 1 generation. Okay, so you can see when the mutation rate is higher, we have 3 mutations. Try it again. Okay, and then you're going to do it for 10 mutations. answer the questions. Okay, and then we're going to go for number 3. We're going to select a mutation rate of 1. We're going to move it to a faster setting, and we're going to try to see how many generations it takes to get to 90% fitness. All right, so let's go ahead and start over. Right now we're at 53, and we're going to go to try and get to 90. This is where I move it too fast. All right, okay. All right, good enough, 93. So it took 47 generations. Oop, okay, with a mutation rate of 1. So I'm not following the progression, but I would go ahead and put it here 2 more times, and then I'm going to change the mutation rate, and do it again. Obviously, right here, I want to try it 3 times under a mutation rate of 0.1 and see how quickly it gets to a fitness rate of 90%. So, okay. When there's not that many mutations happening, this low mutation rate, then it's going to take a little longer for change to happen in the population. Okay, let's keep going. I'm afraid to move it faster. Oh, okay. So you can see that the fitness rate is higher. The insects are better camouflaged, and so this would be 754, okay, give or take. And I would do that a couple more times, get the average. Then I would move the mutation rate up to 0.3 and do it again. Okay, we'll do it one more time. Keep it at a high rate and see if I can stop it at 90. Oh, it looks like 93 is the best I can do. Okay, but you'll notice that it gets to a 90% fitness faster when there's a higher mutation rate. So we'll go ahead and finish that out and see if that seems to be the trend, or if at some point it actually is too high of a mutation rate, that it doesn't have a high fitness. And I think that is all I need to show you. All right, hopefully this is not too painful. Believe it or not, I think this is the 3rd time I'm recording this because I made so many mistakes. But if you have any other questions, feel free to send me an email. Okay.